Introduction to graph traverse. The process of visiting and exploring graph for processing is called graph traversal. That means we traverse the graph from one vertex to another vertex, and we will travel all the vertices and cover all the vertices. This process we can do in several techniques. To be more specific, it is all about visiting and exploring each vertex and edge in a graph such that all the vertices are explored exactly once. That means only once we can visit a vertex. This graph traversal can be done in several ways. One of the ways is BFS. As I already said before, graph traversing can be done in several ways. One of the ways is BFS. What is BFS? How do we do it? And why we need it? All I will explain furtherly. BFS. BFS is known as breadth first search. This is an algorithm that is used to graph data or searching tree or traversing structures. That means by using BFS algorithm, we can traverse the given structure or data or tree. The algorithm efficiently visits and marks all the key nodes in the graph. That means it will visit and marks the nodes that it has visited. This algorithm selects a single node in a graph and then visits all the nodes adjacent to the selected node. This means in this algorithm, first we select a vertex that is called a source node or a source vertex, or we consider the initial vertex as the source node, and then we will start verticing from that source node that we have selected. That source node would be anything from the end or from the middle, from the starting or initial node. You can take any one of them as a source node, but that process should be start at the start at that source node, and from that source node you will visit the adjacent nodes of that source node and you mark the source node as visited. So you all know about BFS. BFS is an algorithm that is used to graph the data. It will visit and marks all the keynotes in the graph. This algorithm selects a single node in a graph and then visits all the node adjacent to the selected node. This is about BFS. Now we have another question. How to do the BFS technique? We see what is BFS and why we need BFS, and we do the BFS by following the given rules. Start by putting any one of the graph's vertices at the back of the queue. That means the selected vertex or the source vertex that you have selected is kept at the back of the queue. That means it is enqueued in the queue as the first element. Take the front item of the queue and add it to the visitor list. That means the enqueued item will be deleted from the queue and added to the visitor list. Then we have to create a vertex adjacent nodes. That means the source node we have selected have some vertices. Thus that vertices are enqueued to the queue after the deleting of the source node, and this will happen until the all the queue going to be empty. That means the first source node that you have selected is enqueued into the queue and then dequeued, and its adjacents are enqueued in the queue, and one of its adjacents is dequeued from the queue, and dequeued elements dequeued element adjacents are again added, and one element is dequeued and dequeued element adjacents are again added. This process is repeated, and we stop this process until unless we get an empty queue. Now we go through a quick review process for BFS. We use queue data structure to implement BFS. We select a node as a source node and add it to the queue. We dequeue the added element and enqueue the essence of the deleted node. And we do this process until the queue is empty. And the deleted elements from the queue are added to the visitor list. This is the process. Let us see an example for the BFS, and here we take 5 vertices 0, 1, 2, and I already said that we have to take a visitor list and a queue, and we taken the graph as undirected. Now now I consider 0 as the source node. If any node is selected as source node, it will be enqueued to the queue and immediately it will be dequeued. And if the dequeued element is written in the visitor list, that means we start from vertex 0. The BFS algorithm starts by putting it in the visitor list. That means we put it in the queue and deleted it, and deleted element is added to the visitor list and putting all its adjacent vertices in the queue. If we deleted an element, what we'll have to do? We have to add the vertices of that deleted element. Here the vertices of 0 are 1, 3, 2. 0 has 3 vertices, that are 1, 2 and 3. These 3 are added. Here the adjacents of 0 are 1, 2, 3 and that are added into the queue. Now the first element in the queue is what? 1. Then that element is dequeued. That means it will be deleted and the adjacents of 1 are added. That means next we will visit the element at the front of the queue, that is 1, and then go to its adjacent nodes. 1 has adjacent nodes 0 and 2. Since 0 is already in the visitor list and 2 is already in the queue, we can't add any adjacents to the queue. If there is another node to the vertex 1 and which is not in the visitor list and which is not in the queue, then we have to add to the queue. If any element is present either in the visitor list or in the queue, we no need to add that element in the queue. By adding the vertices of that vertex 1. This will be repeated for several times until we get the output. We have to get the output. What is the output? An empty queue.